Alrighty, now, I heard some people say they're having trouble with the stuff from Wednesday, so I thought I would go through some examples to help with that. I've got numbers 1, 3, and 6 here written on my paper, and we'll walk through them together, make sure we know all the parts, and we will get this going. If car is going 15 meters per second and does so for 9.5 seconds, how far does the car go in that amount of time? Now, I underlined all the important stuff as we were reading it. Number, question word with a identifier there. So here we are at the first one. We've got 15 meters per second. Remember, if you look at our thing from yesterday, meters per second is a measure of speed, so that's right here. That means we can write our number right here, 15 meters per second. Next, does so for 9.5 seconds. Seconds is a measure of time, so that goes right about here. 9.5 seconds. All right, how far is a question word that asks for distance. So that's where it goes. Now, if you remember, in this triangle on top goes distance. Sorry, I wrote D instead of X. That's very common. X goes on top, T is on bottom, and V is on bottom. So let's fill in the appropriate spots there. All right, we've got V is 15, we've got X is question mark, and we've got T is 9.5. So if we do that calculation, I'm pretty sure we did this actually now that I think about it. But just to make sure we're all on the same page. Okay, so we've got 15 times 9.5 is 142 and 1/2, okay? So we take the two numbers, cover up the X, right? And what's it look like we have to do? It looks like we have to multiply. 15 times 9.5 is 142.5 meters. Okay, good. Now, once again, all we do, we go through, we find the appropriate bits, and we put them into, we define them by either V, X, or T from our equation, place them where they need to go, do the arithmetic. Okay, next, a bowling ball is rolled down the lane with a speed of 3 meters per second. If it travels the whole distance of 20 meters, how long did it take to travel? Okay, so once again, I underlined the stuff as we were talking. 3 meters per second. Once again, meters per second is a measure of speed. 3 meters per second goes where V is. Next, if it travels a distance of 20 meters, distance of 20 meters. I hope that is painfully obvious. 20 meters. How long? Question word. How long usually denotes some sort of time is involved. Okay, so time is our unknown. V is 3 meters per second, and distance is 20 of them. Now we cover up the T, and it looks like we have to take a little division sign here. 20 divided by 3. Is my arm getting in the way of the light? Anyway, 20 divided by 3. Looks like our math problem here. 20 divided by 3 equals some time. Okay, so we do that on our little calculator here. 20 over 3, it's going to be a repeating decimal. Oh my gosh, it's the devil! And that is 6.6 repeating. And we're doing time, so that is in seconds. Okay, so there. Very quick run through for those two problems. Once again, we saw the pieces. We wrote them down on the side. We put them inside the triangle where they belonged, and we did the arithmetic. Now, number 6, this is not going to involve the triangle. You'll notice I didn't pre-draw it here. So what we do here is just like with the displacement stuff. We draw out what's happening, and then we do the physics, the arithmetic / physics of the situation, okay? So the plane is traveling at 300 meters per second to the north. So first thing I'm going to do is I'm going to draw a speed arrow going 300 meters per second to the north, okay? And I'm going to draw my little plane. Of course, you don't have to draw, but I personally find that it's a good choice. That's a decent plane. I've drawn far worse. Okay, there you go. Got your plane. Now, it says, while a wind is pushing south at 25 meters per second. Well, south we know is downward on a piece of paper, right? North, south, east, west. North, south, east, west. So we've got a wind going south. I'll draw it right next to it. And that is going to be going 25 meters per second. These arrows are not to scale. All right, now, what is the velocity of the plane as seen from the ground? So what does it look like the plane's doing if this is the situation? So all you have to do is look at the arrows, okay? If it's going into the wind, as you might expect, that's going to slow it down. So we do the thing we did with vectors before. If it's positive, if it's going up, it's going to be positive. If it's going down, it's going to be negative. So we have a positive 300 meters per second. I'm not sure I'll write out the unit too. And we've got a negative 25 meters per second because it's going down. So it should seem like the plane is going 275 meters per second to the positive direction, which is north. Now, if you apply this idea to number, I believe, what would it be? It'd be 4 and 5. I think those are the ones. It might be 4 and 5 and 7. But if you apply this idea, that'll help. Now, let's say that instead, like on the last problem, whatever it may be, there is a plane that's traveling and there's a wind going south. Right here's a 25. Oh, let's say it's 25. I don't know what it is. And let's say that the plane is traveling at a speed going this way. So let's say it's going to the east. I can't recall what it's actually doing in the problem. And let's say it's going at 100. Remember, guys, when this is the case, if this is your plane, this is what a plane looks like for the sake of argument here. Hey, not bad. There's where the cockpit is. Anyway, if the plane is traveling that way and there's a wind south, if it's going east and the wind is south, remember that we can't just add or subtract like we did a moment ago. We're going to have to do some sort of angular stuff, and we got to find the third leg of that triangle. So we go to Jonathan von Pythagoras. That's not his real name. His name was Pythagoras of something or other, so probably a town. And there's A and B there. 100 squared plus 25 squared equals c squared. Now this is going to be a big old freaking number. So I'm going to do it on the calculator so you believe me. Oh, no, my phone turned off right at the last second. Oh, no, there it is. Okay, so 100 squared is 10 grand. I knew that one. Why did I do that in the calculator? Plus, it's for your sake, right? 25 squared, which is 625. A lot smaller than you might expect. Equals c squared. Now we add those two numbers together, plus 10,000. Okay, we find ourselves with 10,625. Once again, don't know why I put that in the calculator. Take the square root of both sides to find c. And we take the square root there. It looks like our velocity from the ground will be about 103.1 meters per second. And then we are going to the east and south. So I suppose you could call this the southeast. Okay. So once again, with these problems, if they're going in perpendicular directions, remember perpendicular just means 90 degrees between them, right? If they're in perpendicular directions like they are here, you got to do Pythagorean theorem, plug in one leg here, the other leg here, solve for this third leg. And once again, if you think about it logically, this plane would appear to be moving down and at an angle. That makes sense to me, right? Because it's getting pushed down while it's going to the right. So hopefully that was helpful. I know that this stuff can be confusing / it can be disorienting, so I hope that that's useful for you. Have a good one. We'll see you on Tuesday. Get ready for that eclipse, my babies.